Hi all, welcome to this video. I'm Vatsar Srivastav, CTO and co-founder here at CrossTL, and today I'm really excited to present the code structure of our CrossTL repo. Now we've noticed for the past few weeks we've been getting a lot of traction on this GitHub repo, so we decided to make a video explaining the entire code structure for people coming across new on this repo. It could be really confusing, so we decided to just give a debrief there. Um, so, without further ado, let's dive straight into it. The first thing I recommend with any GitHub repo is to go through the README. In our case, we've constructed the README to be extremely minimal, have all the links open straight for any contributor to get started. You can click on our docs, go to our website, understand our mission. Once you've done that, you can look at all the backends we support. Right now, we support Metal, DirectX, OpenGL, Vulkan, and Mojo. Mojo still experimental, but it will come out in a few weeks. Um, Here you can see all the stable backends we support: Vulkan, Metal, DirectX, and OpenGL. You can read about some of the key benefits that CrossTL offers as a translator. As you might know, there's many translators that exist in the field. CrossGL as a company does not want to reinvent the wheel, but we do have certain approaches that differentiate us from existing translators. So in this case, we save time, we are consistent, it's a very simple tool to learn. Just pip install the package, and with a few lines of code, you can translate between these backends. Now, this is what you guys have come for, how it works. There are really 5 steps, actually, really 4 steps of the entire translation process. The first is parsing the code. The second is constructing an intermediate representation. The third is doing code generation on that IR. And the fourth is doing optimizations if applicable. And then the fifth, the final, is the source output. Now, those of you who clicked on the video would mostly be interested in these 4 parts: the parsing, the intermediate representation construction, the code generation, and optimization. Now, the intermediate representation in this case is the CrossGL language itself, which has been carefully constructed and designed to be a unified intermediate representation. Now, those of you familiar with ISO standards or API standards might know this is a basic standards, essentially, a mathematical standard that takes the best elements of each backend and basically integrates it into itself so it can do careful translation. This way, we don't lose any information during the translation. For instance, a vector 4 exists in most shader backends, so we can just directly map that vector 4 to vector 4 operations in the backends. So yeah, this is basically the IR. You can read more about it in our documentation. And then we go over the getting started stuff, how to install CrossTL, how to use it. Again, 1 line of code, you can translate your existing shader code to any backend and vice versa. Again, you can read all of this. You can go through a launch video and everything. Let's write straight into code, actually. That's probably where the meat is. So if you click on the CrossTL folder, the rest of these files are actually really redundant. They're mostly meant for internal usage, apart from the getting started notebook. The rest are mostly for Pipey release licenses and requirements. You can go through them if you want, but they usually don't contain anything core part of the project. The main part of the project is actually in the CrossTL folder and the test directory. So let's go through the CrossTL directory first. Now, the CrossTL directory contains 3 files: underscore CrossTL, init, and source. Init, as always, is just an initialization script, so I'll actually skip that. The underscore CrossTL package is actually a wrapper script. It basically takes your input source file. So in this case, let's say it's a CGL file. Again, CrossGL. CGL is basically an acronym for CrossGL. It can take CGL code and, first of all, check if that file ends with that. If so, it applies certain operations, which we import from the source code. And essentially, based off of the file, it'll apply those operations. Essentially, very basic as far as wrapper code goes. A basic translate function. It contains the translate function, which takes your input shader code, the backend that you want to translate, and the save shader flag, which asks you where you want to save that file, and it returns a string. And again, it just reads which file path you're using, which file you want to translate, and if it's not combinatorial possible, and if you don't support it, then we just give you a trace back. Now let's jump to the main parts of the code base. If you go to the source directory, you'll notice these two folders, the backend and the translator. We'll first start with the translator because that contains the main source code that you need to understand the backend. So let's click the translator. Here you'll notice three files, ast.py, whoops, sorry about that. Three files, ast.py, lexer.py, parser.py. Now, let's start with the Lexer. The Lexer.py. So, first of all, what's a Lexer? A Lexer essentially takes high level code and translates that to a bunch of tokens. Tokens are essentially an easier format to construct and work with on the lower level. So, here you might notice this big list of just one to one maps that we've created. So, each of these are just tokens we're constructing for normal language operations you might see day to day. So, for example, the double operation is mapped to a capital double. So, essentially, stuff that's easier to translate to nodes and stuff. So, here you can see here's a basic compiler logic. So, we essentially just find patterns on the code and we do the mapping to tokens. As you can see, it's pretty self-explanatory. A simple lexer for the shader language. This lexer tokenizes the input code into a list of tokens. It takes your code and returns a list of tokens. Just to kind of illustrate how the lexer works, I've just opened a, let me just clear this up. I've just opened our Mojo backend and I've created this simple example code. It's not actually a working case, but it's just a very simple example of Mojo code where we're just importing the module, doing a decorator, building a basic class, building a basic struct, and we're creating a basic function, putting it all together. Here, I'll essentially not the parser yet. We're basically gonna first look at what the Lexer does. So I've just imported the Mojo Lexer. Here it is implemented. This is the Mojo Lexer, all the tokens that need to be mapped. So first let's initialize this class on this code object. This could be a file path as well. And let's print the tokens that this constructs for the initial source code. Let's run this. And now, as you can see, the tokens are essentially mapped. So we started with this initial source code, and all we've done is basically mapped for example, the import statement to the import statement, the module to an identifier object, the as to another identifier object. And yet, as you can see, we basically constructed it into a format that's much easier to transform than just some abstract syntax. The lexer is explained, the next major part is the ast.py file. Now, those of you who don't really have worked with Python, AST stands for Abstract Syntax Tree. It's essentially constructing a basic syntax tree, a bunch of nodes from abstract syntaxes. It's a more digestible form for compilers in general. That's why we, as a translator, also construct it. So if you look at this ast.py file, it's about 162 lines of code. It's just a bunch of classes that we've constructed. All of them inherit from the AST node to create a hierarchical class structure. And all they do is return a node, which provides more information. Now, the AST are constructed from your list of tokens, and the way they're constructed is all within the parser.py file, which we'll go over in a minute. But essentially, if you look at all of this code, it's just a bunch of classes, a bunch of inputs being constructed into a string format, which is easier to transform. So if you look at it, there's just a bunch of nodes. So there's a node for, there's a node for if, there's a node for assignment, variable nodes. There's a function call node, binary operation nodes, unary operation nodes, and shader nodes. Essentially, all the nodes that we need to take the tokens and construct to a syntax tree. Now, how do we construct this syntax tree is all within the parser. The parser makes reference of both the lexer and the AST. The parser generates an abstract syntax tree AST from a list of tokens. Now, the way it does is we, of course, skip all the redundant code and we eat the tokens that we don't want as part of the code. Again, this kind of shows why tokens are easier to transform. A function like eat is super simple to implement. It's just a few lines of code, really. And the way the parser works is it basically does a bunch of operations, a bunch of if statements, and checks the tokens. And we take tokens that we accept and map to the corresponding AST class over here. So again, the parser is just another simplifying piece of code. It basically takes your input high level language and simplifies it further using the Lexer and the AST classes. So just to illustrate this further, we're going to look at the example that we did here. So let me just clear the terminal. And instead of now printing the Lexer output, we will now print the parser. So again, we initialize the parser class. The parser is for Mojo is implemented right here. As you can see, I basically went ahead and implemented this for the Mojo backend. It's basically doing what the other backend parser does. Now, what we're going to do is parse the output of the Lexer. So we basically initialized the Lexer here, as we previously saw what the Lexer does. Now we're going to pass the output of the Lexer, the tokens, into the parser, because the parser takes tokens as inputs and transforms those. And we're going to now write the output data. We're going to parse the output data into a variable AST, and we'll print that AST to see what we've constructed. So now if we run this code, now if you run this code, now what you'll notice is this is the output. What we've essentially went from is let me actually print the tokens as well, just to show what we've done different. So we basically took a bunch of these tokens and we basically mapped all of that to nodes. So now, as you can see, for instance, the decorator here is mapped to a decorator node, which we got from. Okay, one sec. Again, bad internet. So the decorator, actually, I can just show it from the Visual Studio. So we basically grabbed that from this right here. So we basically mapped it to a decorator node, which references from the Mojo ASD node. So this right here is this representation right here is super useful for doing the code generation and doing for the translation. This is actually our secret sauce for the entire translation that we do, how it works, how that single line of code translate works. Um, so now that you kind of understand what the AST does, what the Lexer does, what the parser does, and how they fit together, we can dive straight into the code gen. Yeah, so the code gen essentially is just actually really simple. It's actually the most simple part of the code base in terms of explanation. It takes all the code that we've generated via the AST, the parser, and everything, and it constructs the source code of choice from that basically AST. It constructs the original source code or the source code of choice from the AST. So in this case, let's say you constructed an AST from the Mojo code, you could directly transfer that to the DirectX code gen. So the code gen, as self-explanatory as it gets, is essentially generating code from the tokens and the AST nodes. Now, actually, we can drive into the backend stuff as well now. The backend also really is just a bunch of code gen and AST logic for backend specific stuff. The front end, if you would call it a front end, is what I've been going through right now, all the Lexer and stuff. That was the front end. The backends themselves contain the AST nodes, the parser, and everything for the specific backend. So in this case, the examples that I shared with you, I was essentially writing the backend specific Lexer and parser for everything. So whenever you come across the CrossTL language and you want to write a backend, the first thing you'll do is go through the translator folder, get a sense of the structure, then you'll go ahead and go to the backend folder, create a new folder, and start creating that same structure for that specific backend. So yeah, again, it's very simple. The backends are just code generation files off the original source code or the target backend that you want to translate to. So the final folder that you'd be concerned about is the tests folder, which are essentially, it's pretty basic actually. It's just the quickest thing you'll learn is just a basic test suite and reconstruction of the original PySource. So in this case, let's just go over the test translator. It has two files that you'd be majorly concerned about. The test lexer, which is essentially a testing of random code samples into the tokenized function. The tokenized code is just a lexer and tokenization of the original source code. Same goes for the parser, which is the same thing but for parsing the code. And yeah, it's essentially if you code anything on the front back end side, you just basically want to write a corresponding test to make sure it's all working based off of a test input and output. And the same goes for the code gen. It's just a basic reconstruction of the code. So that's, I think, a wrap of a high-level overview on the CrossTL repo. CrossTL repo, sorry. We're extremely excited to see what you guys do and how many contributions we get. Again, any contribution is welcome on the repo, big and small. So really excited to solve the fragmented field of graphics with you. If you like what you saw, give a like on the video, start our GitHub repo, and feel free to drop any questions on our Discord server linked below. Have a nice day, everyone. Cheers.